Hi everyone, I hope you've been having a good week. I've been enjoying reading your work on computational thinking, and I've been enjoying going through your Scratch programs and seeing some of your initial efforts with that software. Please explore each other's Scratch programs, and as you do so, click on source code every once in a while if you want to see how somebody did something. That's one of the really cool things about Scratch is that you can always click on the source code and see what the person did and how they did it. So it's a really good opportunity for stealing good ideas and figuring out new things about Scratch that you didn't know before. We can really use a program like Scratch to learn from each other. Last week we read a lot about computational thinking and had some discussion about what computational thinking was, and then you did some work with Scratch. I think one of the issues with computational thinking and one of the criticisms is that people sometimes simplify it and they think it's about getting kids to think like computers. And of course, that's not the case. What we want to do through computational thinking is more along the lines of getting kids to think like computer programmers or engineers or scientists or researchers. It involves helping students develop a kind of disciplined thinking where they can break down problems, um, test out different hypotheses, try different things, and go about in a systematic way solve problems. So this is something that we don't want. We don't want to turn students into just computational thinkers, but what we want to do is we want to add computational thinking to the repertoire of strategies, of thinking strategy that students have. So in addition to computational thinking, we want them to be creative thinkers and critical thinkers and so forth. But computational thinking is one of the very important types of thinking that we hope they can develop. Now, in a number of weeks, you've got an assignment due, and this will be your first assignment in the course, and it's going to involve creating your own Scratch program. So what I'll be doing over the next few weeks is I'm going to be giving you a little bit of Scratch instruction so you know how to use different aspects of Scratch. Now the four goals of this assignment are: first, I want you to become familiar with Scratch because it's some software that you can use in your own classes when you're teaching. I want to give you some experience coding so you understand from the learner's perspective what coding is about and how people go about learning to code. And you'll find there's an awful lot of trial and error in learning how to code. You try different things and you see what the effect is. I also want you to think about and learn about computational thinking concepts, and we've been doing some of that this past week. And lastly, give some thought to how computational thinking might be introduced into the classroom. So those are the four goals for this first assignment. Now, this week in Scratch, I'm going to be introducing two very fundamental coding concepts to you. One is called looping and the other is called conditionals. And looping and conditionals are part of just about every programming language there is. Looping means taking a series of statements, a series of instructions, and looping over them repeatedly, um, either a set number of times or until a certain condition is reached. So you'll see how we can do looping in Scratch, and I've created a little video that gives you a demonstration of some different types of loops you can create. The other key concept is conditionals. And a conditional just means is just what we also call an if-then kind of situation or an if-then-else. So it basically says if a certain set of criteria are met, execute these commands. Otherwise, don't do anything, or otherwise do these other commands instead. So that's essentially what a conditional is. It's just an if-then-else construct within coding. And I've created some video there as well that shows you how conditionals work in Scratch. And these are foundational, again, in all languages, so whether you're programming later in, say, something like C or BASIC or PHP or JavaScript or whatever, you'll find these fundamental concepts in those different types of programming languages. Okay, so those are the first coding principles we'll be looking at, and I'll be teaching you another couple next week. Have fun, and I think you'll find Scratch fun, easy to use, um, and forgiving too. So be really brave and experiment with different things, try different things, and see what happens. Okay, see you online.